Dear friends, welcome to my video. Kindly click on the CC button for subtitles. Quantum physics and relativity are two fundamental pillars of modern physics, each shaping our understanding of the universe in its own unique way. Both theories have stood the test of time and numerous experimental confirmations. Yet, their profound differences have opened up one of the most intriguing and unresolved questions in physics. How can we reconcile quantum mechanics with general relativity? Quantum mechanics emerged in the early 20th century, revolutionizing the way we think about the microscopic world. The bizarre, counterintuitive predictions of quantum mechanics challenged the classical deterministic understanding of the universe. Quantum mechanics describes particles not as point-like entities moving along well-defined trajectories, but as wave functions spread out in space and time. The act of measuring a quantum system collapses this wave function, manifesting a particle in a specific location. Quantum mechanics also introduces the principle of superposition, where a particle can exist in multiple states at once, an entanglement, where the state of one particle can instantaneously affect another, regardless of the distance separating them. On the other hand, Albert Einstein's theory of general relativity, also a product of the 20th century, tackles the macroscopic world, the universe at large. This revolutionary theory explains gravity not as a force but as the curvature of space-time created by mass and energy. Predicting phenomena like the bending of light around massive objects, gravitational lensing, or the slowing of time in high gravitational fields, time dilation, general relativity has changed our understanding of space, time, and gravity. The trouble arises when we try to combine these two theories. Quantum mechanics treats particles and their interactions in a probabilistic manner, while general relativity relies on the deterministic principles applied to the fabric of space-time. Quantum mechanics deals with the discrete quanta of energy, while general relativity handles the continuous space-time. Quantum mechanics is excellent at handling the very small, atomic and subatomic particles, while general relativity beautifully explains the very large, stars, galaxies, and the universe itself. For most practical applications, this division of labor isn't a problem. We use quantum mechanics for atoms and tiny particles, general relativity for stars and galaxies, and never the twain shall meet. However, there are realms in the universe where both theories are crucial, in the heart of black holes, or at the very moment of the Big Bang. These are the realms of quantum gravity, and this is where the two theories clash. The key issue lies in their incompatible views of space and time. In general relativity, space-time is a smooth, continuous fabric, but quantum mechanics suggests that at the tiniest scales, it may be grainy and discrete, a sea of quantum foam. Attempts to quantize gravity have so far led to mathematical inconsistency and physical absurdities. The quest to reconcile these differences and formulate a unified theory of everything remains one of the grand challenges of modern theoretical physics. String theory and loop quantum gravity are among the leading contenders, but both have yet to provide experimentally testable predictions. Despite these challenges, the intellectual pursuit of unification continues, driven by the belief that the fundamental laws of nature are ultimately coherent and unified. In conclusion, quantum mechanics and general relativity, though different in their principles and predictions, have transformed our understanding of the universe. They stand as twin pillars supporting our knowledge of the physical world. The quest to reconcile them into a unified theory is not just an academic exercise, but a journey to uncover the deepest truths about the universe and our place within it. The day we achieve this will not only be a triumph for physics but for human intellectual achievement as a whole. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.